I'm going to take a really different sort of approach, knowing my esteemed colleagues were speaking before me and that they would cover lots of detail. I'm going to actually throw out a bit of a challenge, I suppose, in what I'm going to talk about today, and you might hail me down at the end of it, that's fine. But I want to think about the concept of innovation and how we actually think about innovation and what we can actually learn. So, now, spectroscopy. Sorry, no, I didn't swear at you. Okay, spectroscopy, there's a definition of it there for you. So it is the interaction between matter and energy from any portion of the electromagnetic spectrum. And basically, in that, and in our, if you go to the bench, if you like, there are lots of different types of spectroscopic types of devices that exist. And I'm going to talk about particularly one of those today that we've been doing some work on in the last few years, called Raman. There's NIR, and there's other sort of devices. So when we were thinking about how we actually might apply these technologies and where they would fit, also just thinking about the industry. And as you will know, if you're a processor, and some of the big processors are running pasture-assured beef programs. And there's significant premiums to producers if you fill out all the paperwork and apply and comply with what the processor wants you to do, that you'll get a significant benefit from actually supplying pasture-assured beef. So the question is, okay, now that fits in with the fact that there's a global trend. It's actually in the AMPC document, identifies that consumers are really concerned about misrepresented products, and particularly in Asia, there's a real focus on quality, particularly amongst those we've heard this morning that actually got the ability to pay for that product. They're really concerned about where that product come from and what's behind it, and actually, if you like, the authenticity of it. Now, recently we did a survey. It was actually a worldwide survey. We surveyed 2,700 consumers across the globe. A lot of those were in China, and we're particularly looking at actually people's response to meat colour. But as a part of that, we also asked them questions about the things that they considered important. And production system, amongst 30% of those consumers, was ranked as being important. So we know that base, and the base is the same in China. We had a visiting scholar for a year, and when he came, I said, one of the things I want you to do is to write a paper on consumer attitudes in beef and lamb. What do they think about, what do they like, and all the demographics of China. And that was a great exercise because he had the access to a lot of documents in Mandarin that I couldn't read, and it's a really informative document. And it's the same message that comes through there. There's an element of consumers that are really interested about the product that they eat. Recently there was a paper published in the journal Meat Science where these quality intrinsic attributes, including production system, were ranked as being important. So the question is, if you're a processor and you've got this system of pasture-assured beef and you're asked to actually verify that the beef is actually grass-fed, at the moment, you have to rely on a certification system, an auditing process, vendor declarations. But would that actually be sufficient? If you had the paper trail, yes, you've got the paper trail, but it's all gone. The product's sold, it's gone. So what could you do to actually, if you like, beef up that system? Excuse the pun. And what's at risk? We talked a lot about the Chinese market. You know, just the chilled market, $60 million a year. What happened if Chinese consumers were saying, well, we want to know more about this product. Is it really grass-fed? Is it really healthy? So maybe there's a more scientific approach that we could take to this verification procedure. Something that you could say, you could hang your hat on and say, no, we've got some evidence that this is grass-fed beef. So this is where Raman fits in. Now, for the last few years, we've been doing some work funded by AMPC. We had a PhD scholar who worked on this project. And one of the things about these technologies is that they are, in fact, relatively rapid. They're non-destructive, they're non-invasive, you don't need to prepare samples, and you don't need bulky equipment. And I'll get to that point too, because that's really important in terms of one of the developments that's actually happening in this space. And some of the things that we're trying to predict in the product, in the meat, could take you weeks to actually go away to a laboratory and actually get an estimate of what's actually in that meat. So that's the advantage. So Raman's an interesting area of spectroscopy, and basically what you're measuring when you put light into the matter, in this case meat, energy, you actually get this Raman scattering. Now, the concept was discovered by an Indian physicist in 1912, C.V. Raman, hence called Raman Spectroscopy. And basically, it's very unique in the sense that it gives you a good chemical fingerprint for whatever the thing is that you're measuring, whatever the matter is, whether it's liquid or whatever. Now, we were doing some work for, I suppose, 3 years with a German colleague, very smart individual, physics, chemistry background, and he had developed and built a Ramen probe. So this is a handheld probe, and forget the red light working. So up here, basically you need a laser, and the laser emits light at a particular wavelength, and it's got to be a very specific wavelength. And essentially then, in simple terms, sample here, and we measure the Raman light that comes back, the Raman scattering. Now, something like meat is an in-between Raman scatterer. If we measured fat, it's a very good Raman scatter. That's pure fat. Water, it's not a Raman scatterer. So actually that helps us when we're actually interrogating things like meat. So this device here, whoops, go back. So this device, go back. This device here is still relatively portable, but it's hooked up to the spectrophotometer, and you get essentially out of here some sort of thing that looks like that. That's a spectra. So it's got a whole lot of peaks which are actually identifying the chemical structure of the thing that you're interrogating. And that's actually the probe in operation. So here, it's actually been used in situ. This is on a lamb carcass, and here on the top side, taken out of the carcass. You can see very intense light. And so we've done quite a bit of work with that technology. And we know from the literature, and in fact, some of the first work that was done with benchtop machines was actually done in Ireland, but across the border, Declan in Northern Ireland. And you can use this technology, bench tape machine, which if you go to the University of New South Wales, they've got one, and you can identify the species of origin from fat by actually scanning the fat. Some of the work that we've done, we've discovered that in fact there's good potential to actually identify differences in the fatty acid profile of meat by using this particular technology. Now we know, when we come back to the pasture assured program, for instance, that the pasture assured animals should have much higher levels of omega-3, health claimable fatty acids like EPA, DHA. And the grain-fed ones will have more of the N6 fatty acids. So, what about our ability to discriminate? If you look at this particular slide, you'll see that there are 4 places in red that are identified. And each of those, so at the top one here, at this peak here is due to samples that have actually got a higher level of polyunsaturated fatty acids, so like those omega-3s. All these peaks. Now, with a lot of mathematics, we can work out and discriminate then between 2 different samples. So here we have potentially a technology that we could use to run over samples, in particular, if I said if it was pure fat. This is actually in meat, okay, and as I said, meat's not quite as good Raman scatterer. Fat is actually better. So if you were to measure fat, we anticipate that those peaks would actually separate even more. And potentially then you've got a technique you can actually screen product with. So this is where the innovation comes in, because here we have a Ramen probe. It's as big as your hand. It's a commercial product. It's out on the market. And recently we did a little bit of work with this product. So here we've got innovation. Now when I talked to this company, I said, what was the motivation for you to develop this particular piece of technology to that size? And not the only one in the market, there are others in the market also. But you think about our colleague started off and built his own probe 5, 6 years ago. It was much bigger than this. And in that time, industry has actually innovated and developed. Now, with Ramen, you can do things like detect explosives very well. You can detect drugs very well. And one of the main motivations for the development of this technology was in fact the US military. These things are used in the field for detecting explosives. So here we have another industry, another need, developing a piece of technology that potentially we can use to solve an issue or what could I say could be an issue in the meat industry. So what's the lesson? The lesson is that there are technologies there that we can, if we've got the right scientific approach, potentially adapt and use as we service the industry. And it's just one example of those piece of technology. It's interesting, Robin was talking about Smart Stretch. We did most of the work on Smart Stretch in Australia, both in beef and lamb. And one of the staff that worked for me did a master's on it. And we think about that integration of industry taking up technology. We ran 30 demonstrations across Australia, and I'm guaranteeing in this room that there's processors who had that equipment in their facilities. Smart Stretch wasn't the adoption of that technology at the end. What was it? It was Smart Shape. So it was actually taking the technology using a cold bone product and shaping the product. And so there's a real lesson there about how we actually, if you like, transmit information and develop technology. So that's Raman. We have demonstrated you can actually also predict things like pH, ultimate pH, purge, and we've done some recent work with consumer satisfaction and got some reasonable results in terms of predicting eating quality. Interestingly, you can also potentially use this for bacterial levels. And unrelated but not the same technology, using NIR, there is an ability to actually detect also animal age very accurately. And there's a project, hopefully, that MLA is going to start very soon in that space. So I talked about bacteria. This is a PhD from the US. And the symbols in green are E. coli 0157. And you can see that they're all E. coli, but it discriminates really well that particular bacteria from the other 3 E. coli strains. Very interesting. So, going forward, what do I want to leave you with? Basically, the developments in technology need to be captured as we look at whatever the issues are in the industry, what are the things that are limiting us. We need to be able to capture the technology. And I've given you a particular example of that. And my last plea in terms of the industry is the last one. We need investment in the next generation of meat scientists because we need the people to actually be able to capture this information, evaluate it scientifically, work with industry, and we're always working with industry. All our projects are pretty well done within Processing Works so that we can actually bridge that gap. That photo of the lamb carcasses, all done in a New South Wales processing establishment. Thank you.